In 2024, United States retailers absorbed $890 billion in return-related costs. The fashion sector carries the heaviest share. Apparel return rates run between 24 and 40%. During promotional windows, the rate spikes to 88%. The leak in the P&L is not marketing, it is geometry. 53 to 67% of those returns trace to a single failure, fit. The industry has answered with generative AI diffusion-based virtual try-on systems that paint plausible images of the customer in the garment. The thesis of this brief is direct. The fit crisis is not a semantic problem of visual plausibility. It is a geometric problem of mechanical compatibility. Pictures cannot solve it, physics can. Latent diffusion models VTON HD IDM-VTON LEFA operate in two-dimensional pixel space. They sample from a learned probability distribution over images, then denoise toward a coherent picture. They carry no internal representation of depth, volume, or fabric stiffness. 3 failure modes follow. First, mode interpolation. The model averages between styles in its training set, draping a stiff A-line skirt with the softness of a maxi dress. Second, slimming bias. Trained on idealized fashion photography, the model warps the body or stretches non-stretch denim to force a flaring composite. Third, geometric inconsistency. Sleeves merge into torsos, patterns slide off the curvature of the body. The output is an illusion of fit, a high-confidence purchase the physical garment cannot honor. The physics-based pipeline replaces hallucination with measurement. 5 stages. Stage 1, human mesh recovery. A Vision Transformer backbone, the successor to convolutional networks drawn from the HMR 2.0 architecture, regresses the parameters of a parametric body model from a single monocular photo. The model is SMPL-X, which adds articulated hands and an expressive face, or its biomechanically constrained successor. SKEL, which enforces joint limits derived from medical data and eliminates rubber limb artifacts. Stage 2, perspective correction. A selfie taken close to the face creates fisheye distortion that breaks any naive measurement. The BLADE algorithm explicitly recovers the camera's focal length and the subject's translation along the z-axis, then inverts the perspective. The reconstructed body lands within 1 to 2 centimeters of a manual tape measurement. Stage 3, the garment. The brand's actual digital pattern, a DXF or GLB file authored in CLO 3D browseware or Optitex, is imported as a mesh of nodes connected by springs. Stage 4, simulation. A finite element solver runs partial differential equations over that mesh, parameterized by 3 mechanical properties measured under the Kawabata evaluation system: tensile stiffness, bending rigidity, and shear stiffness. Gravity, collision with the avatar, and fabric anisotropy resolve to equilibrium. Stage 5, the output, a stress-strain map. Red zones mark strain above 100%. The fabric is compressing the body. Yellow is snug, blue is loose. White means no contact. The customer no longer sees a picture. The customer sees a measurement. The numerical case for replacement is concrete. National Retail Federation data places total U.S. return costs at $890 billion in 2024. 53 to 67% of apparel returns are fit-driven, according to industry analysis. 51% of Gen Z shoppers report regular bracketing, ordering multiple sizes with the intent to return all but one, which doubles outbound logistics and locks inventory in transit. The processing cost of a single return runs $10 to $20 in direct handling, including depreciation, refurbishment, and customer acquisition waste. Total damage reaches 66% of the item's original price. On the engineering side, BLADE achieves 1 to 2 centimeter measurement accuracy, the threshold required for reliable size recommendation. Independent industry studies on advanced virtual try-on deployments report return rate reductions of 20 to 30% when the system delivers verifiable fit rather than approximate visualization. The benchmark is no longer whether the image looks photoreal. It is whether the prediction holds when the garment arrives at the door. Consider a mid-sized fashion retailer at $200 million in annual gross sales. At a 30% return rate, $60 million exits the warehouse and returns to it. At 20% processing cost, $12 million goes to logistics, labor, and depreciation each year. A 25% reduction in returns, the lower band of published gains, yields $3 million in direct savings. Add the revenue recovery from preserved sales, and the total P&L benefit reaches $10.5 million annually. The EU Ecodesign for Sustainable Products Regulation now restricts the destruction of unsold textiles. Wrapper AI buys conversion. Physics-based reconstruction buys the margin back. This is the geometric imperative. Read the 15-page brief, about 22 minutes, for the full pipeline derivation, the cost cascade table, and the ROI model. Veriprajna, building true intelligence.